So I want to look at the conjugate roots theorem, and it's another piece of the polynomial puzzle that helps make sense of the zeros of a polynomial. And so here's what it says. If you have a polynomial with only real coefficients, okay, if a plus bi is a 0 of p, then the conjugate of that, a minus bi, is also a 0. Okay, so this can help us factor some stuff if we have already found a complex 0. And again, what we mean by conjugates is the conjugate of a plus bi is a minus bi. These two are conjugates of each other. And let me give you an example of how the conjugate roots theorem can be useful. Okay, so here we're asked to factor f of x, which is x to the fourth minus 8x cubed plus 200x minus 625. And what we know is that 4 minus 3i is a 0. Okay, now by the conjugate root theorem, 4 minus 3i can't show up by itself. We have 4 minus 3i and 4 plus 3i are both zeros. Okay, so that means when this thing factors, f of x actually equals x minus that 4 minus 3i times x minus a 4 plus 3i times some other stuff I'll just call g of x. Okay, and actually if we go ahead and multiply these complex expressions out, maybe it can help us figure out what this g of x is, and maybe that's something we could factor, and that's actually the approach we're going to use. So let's take a look at that. So I'm going to try to multiply these two together. That's going to be x minus a 4 plus 3i, once I distribute the negative, times x minus 4 minus 3i. Okay, and when I multiply those out, the way you have to think about this, remember it's just like distribution. That's what the FOIL method is. Just everything gets its turn to multiply across everything else. Okay, so first we have the x's. That's going to be x times x, which is x squared. And then I have a minus 4x and a minus 3ix. That takes care of this x. Now we're going to move on to the negative 4. And I have a negative 4x plus 16 plus 12i. And then lastly, we move on to the 3i. And we end up with a plus 3ix minus 12i plus 9i squared. Okay, and that takes care of the 3i. And there we have it. Now if you notice some things cancel out, let's think what cancels out here for us. How about the positive 3ix and the negative 3ix? The positive 12i and the negative 3i. Okay, and we can also reduce this 9i squared, because remember I squared is the same as negative 1. So that's actually a negative 9. And I think I made a mistake here. This is actually a negative 9i squared. So actually this all becomes positive 9. So once this reduces, you end up with x squared. How many x's do I have? A negative 4x and a negative 4x. Gives me a negative 8x, and then I have a plus 16 and 9, which gives me a 25. Good. So again, I made a mistake here. The 3i times negative 3i should be negative 9i squared, which ends up becoming positive 9. 16 plus positive 9 gives me the 25 here. Okay, so that's what all this multiplied together is actually just x squared minus 8x plus 25. So what we have so far is that f of x is this x squared minus 8x plus 25 times something. And we don't know what that thing is. How can I figure out what that is? Well, we could use division. And we're going to use polynomial division, but since I'm dividing by a quadratic term, I can't use synthetic division. We're going to have to go back to long division. Alright, so let's take a look. Okay, so we're going to do polynomial long division to factor this. And don't forget, since we didn't have a squared term, I need to put in a 0x squared there. And how do I do polynomial long division? I have a video going over that if you need it, but we'll go over it again here. So I need to think x squared times what will give me x to the fourth? Well, x squared times x squared will give me x to the fourth. And then I distribute the x squared across. And so I have x squared times x squared, which is x to the fourth. X squared times the negative 8x, which is a negative 8x cubed. And then x squared times 25 gives me a 25x squared. From there I'm subtracting, so I'm going to flip my signs on everything. And when I do that, I end up, let's see, I have a 0x to the fourth, actually a 0x cubed as well, and then end up with a negative 25x squared. And I'm going to go ahead and bring down my 200x and my negative 625, and we're going to play this game again. So now I need to think, okay, what times x squared will give me this negative 25x squared? Well, how about negative 25? And so when I distribute the negative 25 across this polynomial, I end up with a negative 25x squared. A negative 25 times negative 8x, that ends up with a plus 200x. And then a negative 25 times a positive 25 gives me a negative 625. And I think you can see what's going on here now. But remember, I'm going to subtract. So when I subtract, I'm going to flip all my signs. And when I do that, I end up with a 0. And that's a good thing. The 0 is my remainder. And so that means this thing is now factored. And so f of x actually then equals x squared minus 8x plus 25 times what? What we just got as our quotient, which is x squared minus 25. And x squared minus 25 actually factors because it's the difference of two squares. So I have 8x squared minus 8x plus 25 times x minus 5 times x plus 5, right? The difference of two squares. And so there it is. I have factored this polynomial, and I know my zeros are going to be, from this first thing, remember, I had my zeros to be 4 plus and minus 3i, the conjugates, and then lastly I get 5 and negative 5. And there are my 4 zeros of this polynomial that I found through factoring. In theory, the conjugate roots theorem is saying something very simple. All it's saying is that for polynomials, the complex zeros show up together in pairs through this conjugates. And so using that fact, if we find 1, we have found 2 zeros. And that'll help us factor these polynomials using division. Okay, I hope this makes sense. If you have any questions on any of this, I'd be glad to help. And thank you for watching.